Welcome back. In this lecture, I will talk about mapping deprived urban areas. The rapid urbanization that is taking place in many parts of the world, and especially in low and middle income countries, often results in the proliferation of deprived urban areas, commonly called slums or informal settlements. The people living in these neighborhoods often lack access to clean water, sanitation, electricity, healthcare, and other basic services. According to official UN statistics, there are currently 1 billion people living in such deprived urban areas. However, these areas are often invisible in official maps and statistics. This information gap hampers the development of effective upgrading projects. Earth observation can help us map and monitor the evolution of these urban areas, offering a better understanding of these complex urban processes. Urban deprivation is a global challenge that is recognized by the SDG agenda. SDG 11 aims to make cities inclusive, safe, resilient, and sustainable. Target 11.1 and Indicator 11.1.1 focus more specifically on slums, requiring nations to ensure adequate, safe, and affordable housing, and estimate the proportion of urban population living in slums, informal settlements, or inadequate housing. Earth observation allows us to assess this indicator more efficiently than traditional household surveys. Machine learning makes the data analysis more efficient while ensuring objective and reproducible results. Moreover, the geospatial information is often fundamental for targeting interventions aiming at improving the living quality of the local communities. Mapping slums is nevertheless an extremely challenging problem, also from an image analysis viewpoint. First of all, the semantic definition of the class slums is abstract, and different countries tend to use slightly different definitions. Second, standard pixel-based methods cannot capture the complex spatial contextual features to perform accurate classifications. Look at the image on the right side of this slide. Can you spot the slums? I'll give you a hint. As you can see, slums are generally very densely populated area, characterized by poor roof material and often the absence of vegetation. Past studies have adopted object-based image analysis and texture features to capture these characteristics and obtain accurate results. State-of-the-art methods are based on deep learning, such as convolutional neural networks, that can learn these complex spatial features directly from the input image. A few years ago, we introduced fully convolutional networks for mapping informal settlements. This type of networks are designed to perform pixel-wise classification, which is also called semantic segmentation in the computer vision literature. For this purpose, we used convolutions with dilated kernels that capture large receptive fields without downsampling layers or increasing the number of learnable parameters. The network design was at that time quite simple compared to modern deep learning architecture. If you want to know more about the technical details, please check the paper reported at the bottom of the page. This slide shows the experimental results we obtained on a dataset from Dar es Salaam, Tanzania, and the proposed fully convolutional network with 6 dilated kernels named FCN-DK6 outperformed alternative methods such as pixel-based support vector machine and a patch-based CNN. Moreover, the inference time of the proposed method is much smaller compared to traditional CNNs. Now, I want to briefly share with you our work on the project Idea Atlas, which is funded by the European Space Agency. The aim of this project is to design AI-based solutions for the SDG 1111 reporting. Our approach aligns with the slogan, Global Challenges, Local Action, emphasizing the need to consider the local culture, legislation, and community needs. We focus on 8 cities around the world, as reported in the figure at the bottom right side of this page. And in each of them, we have local collaborators who help us collect data and co-design the AI-based solutions. We mostly use open data from the Sentinel program, focusing on fusing optical and SAR images for mapping the informal settlements and resort to very high-resolution images where needed. We aim to deliver 3 sets geospatial products. First, the slum extent maps for all 8 cities, 1 per year, starting from 2019 to 2023. Second, going beyond the binary maps, we will generate slum severity index, representing the deprivation level of each slum. And third, we will produce statistics aggregated at the city level, including the SDG indicator 1111. And the diagram you see on this slide provides an overview of our strategy. Okay, let me conclude this short video with some final thoughts on remaining challenges and future work. First of all, Sentinel data are great as they are free and open, but the resolution of 10 meters is often a limitation, especially for characterizing the morphology of urban areas. Second, from a machine learning perspective, one of the challenges is to improve the generalization ability of the model, which is fundamental for large-scale applications. Next to that, more emphasis should be given to make AI models trustworthy and possibly explainable. This is very important for using AI-based results in support of decision-making. Data quality and uncertainty quantification is also extremely important for real-world applications and should be explicitly incorporated in the AI-based workflow. And a final observation. We see a paradigm shift in AI. We are moving away from model-centric AI, where most of the effort is spent on the model design, towards what I call data and user-centric AI, where more emphasis is given to the curation of high-quality datasets in close collaboration with end users. This is also a quest for machine learning experts to work in cross-disciplinary teams. Okay, this is all for now. Thank you very much for your attention and see you in the next video.